hole is a region in space where the pulling force of gravity is so strong that light is not able to escape. The strong gravity occurs because matter has been pressed into a tiny space. This compression can take place at the end of a star's life. Some black holes are a result of dying stars. Because no light can escape, black holes are invisible. However, space telescopes with special instruments can help find black holes. They can observe the behavior of material and stars that are very close to black holes. Black holes can come in a range of sizes, but there are three main types of black holes. The black hole's mass and size determine what kind it is. The smallest ones are known as primordial black holes. Scientists believe this type of black hole is as small as a single atom, but with the mass of a large mountain. The most common type of medium-sized black holes is called stellar. The mass of a stellar black hole can be up to 20 times greater than the mass of the Sun and can fit inside a ball with a diameter of about 10 miles. Dozens of stellar mass black holes may exist within the Milky Way galaxy. The largest black holes are called supermassive. These black holes have masses greater than 1 million suns combined and would fit inside a ball with a diameter about the size of the solar system. Scientific evidence suggests that every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the center of the Milky Way galaxy is called Sagittarius A. It has a mass equal to about 4 million suns and would fit inside a ball with a diameter about the size of the Sun. Scientists know about one way that black holes form, but there may be others. One way to make a black hole is to have a massive star collapse at the end of its life. Professor Subramanian Chandrasekhar was the first to calculate that when a massive star burns up all its fuel, it will collapse. The idea was ridiculed at first, but other scientists calculated that the star continues forever to fall inward towards its center, thus creating what we call a black hole. Black holes can grow more massive over time as they eat gas, stars, planets, and even other black holes. Primordial black holes are thought to have formed in the early universe, soon after the Big Bang. Stellar black holes form when the center of a very massive star collapses in upon itself. This collapse also causes a supernova or an exploding star that blasts part of the star into space. Scientists think supermassive black holes form at the same time as the galaxy they are in. The size of the supermassive black hole is related to the size and mass of the galaxy it is in. Black holes have two parts. There is the event horizon, which you can think of as the surface, though it's simply the point where the gravity gets too strong for anything to escape. And then at the center is the singularity. That's the word we use to describe a point that is infinitely small and infinitely dense. Black holes are invisible. A black hole cannot be seen because of the strong gravity that is pulling all of the light into the black hole's center. However, scientists have developed several ways to find them anyway. By looking for the stuff that's falling in. If material is falling into a black hole, it travels at such high speeds that it gets hot and glows very brightly. And we can detect that. That's how the Event Horizon Telescope took its famous first images of black holes. Scientists hope to use this method to learn a lot more about how and what black holes eat. By seeing their gravity pulling on other things, we can find black holes by watching the movements of visible objects around them. For example, a black hole's gravity is so strong that nearby stars will orbit around it. So we can look for a star behaving strangely around a patch of empty space. From this, we can calculate exactly how heavy that black hole must be. That's how Nobel Prize winner Andrea Ghez and her team detected the supermassive black hole at the center of our own galaxy. By detecting the gravitational ripples when they collide. We can also detect black holes by detecting the ripples in space-time created when two of them crash into each other. From that signal, we can tell how massive the black holes were, how far away they were, and how fast they were traveling when they collided. Contrary to what you may have seen in movies, black holes don't actually suck things in. For example, there are actually stars orbiting the supermassive black hole at the center of our galaxy. And they will keep orbiting without falling in unless something else disturbs them. An object really has to fall right into the mouth of a black hole for it to be eaten. And the mouth, which we call the event horizon of a black hole, is tiny. If the entire Earth were to collapse and form a black hole, its mouth would be less than an inch across. But the movements of stars and galaxies do sometimes mean that stuff falls into a black hole's mouth. Sagittarius A, the black hole at the center of our galaxy, mostly eats interstellar gas and dust that is drifting around. With telescopes, we have seen other black holes eating stars and even the gas from neighboring galaxies. Black holes can be messy eaters. As objects are being ripped apart, some of the gas and matter can be flung off at high speeds. Sometimes this is so powerful that it forms jets and winds shooting outwards at nearly the speed of light. And this can affect the galaxy containing it. These jets can blow apart nearby stars and planets, or they can provide just the right amount of churn to create the ideal conditions for making new stars over millions of years.